So we're going to diagnose this battery today to determine whether the issue with it is the BMS or the battery itself. Now, a little bit of history. On this scan data that we have in the class chart, you will see that cells 37 and 38 of the high voltage battery are reporting 0 volts at one point in time, as well as higher than usual voltage when the car is driving. So we need to determine whether the problem is the BMS or the actual high voltage battery. To do that, in front of us here we have the pinout data for the BMS. If you look at the connectors, you're going to see connector BO1VE. It's a 40-pin connector. This is the connector that we are going to be paying more attention to today. When you come down to this part of the diagram, you're going to now see battery cells displayed on the diagnostic tool, KDS/CDS. So modules are listed out on this left hand side. Each module has 16 cells. We are concerned with 37 and 38. 37 and 38. 37 and 38 falls within module 3. We see 37 and 38. So 37 will be BO1VE, which is the same 40-pin connector. 38 will also be on the same 40-pin connector. The pins we are concerned today with will be pin number 3 and pin number 23 for cell number 37 voltage, and pin number 4 and pin number 23 for cell number 38 voltage. To verify that we are on the correct, we are testing the correct wires, we now proceed to the wiring diagram, where we are to see the colors of the wires that we are concerned with today. So this is the wiring diagram we have here. As you can see, 1 and 2 are the modules. So these are not what we are concerned with. The center will be the BMS. 3 and 4 is where we are concerned. We are concerned with 3. So this is cell number 3, I mean module number 3, and the BMS is here. We are concerned with pin number 3, pin number 4, and pin number 23. Pin number 23 will be a grey wire on the wiring harness. Pin number 4 will be a green and white. Pin number 4, sorry, will be a grey and orange wire. And pin number 3 will be a green and white wire. By testing these 3 wires, we will be able to determine whether the battery voltage is reaching from the battery to the BMS. If that is the case, then we can safely determine that the BMS has an issue. It's not interpreting the voltage being sent in. Okay? So we proceed to test now. From the connector view, we can see pin number 3 and pin number 23. Now remember, pin number 3 will be the green and white wire, which we have here, and pin number 23 will be the grey wire. So we would now put in the grey pin number 23, which will be the third one down here. 1, 2, 3, right? And pin number 3 will be directly above it. Okay, if you look at the multimeter now, you will see that we have 3.743 volts. So you will note this. What I will do now is rock the harness to see if I'm seeing a fluctuation in the voltage, because at the end of the day we need to ensure that we have no shorts. I'm currently rocking the harness for module number 3, and as we can see, we have a steady connection. The voltage is steady. Agreed? Right, so the next test will be to test pin number 23. So you're remaining down here, and we move into pin number 4. And we have 3.681 volts. I shall do the same thing. Rock the harness. Make sure I rock the harness everywhere, and that we are not getting any fluctuation. So we have no fluctuations there. However, to verify the test, we must test a known good one. So the known good cell will be 6 and 26, 25 and 6. So set 25 in the bottom. That's 25, yep. And go to 6 on top. So 25 and 6 will be cell number 41. Let's now verify that. 25 and 6, cell number 41, and we have 3.684, right? And 685 now, we can rock the same way just to verify. because this is the harness going to it right here. This is module number 3. We have nothing there. Okay, now we're going to 26 and 6. 26 and 6, and we have 3.687. Now that we have done this test, why we can confirm that the module is sending voltage through the harness connection all the way to the BMS plug, we have seen an issue. The issue that we have seen is module voltage variation, cell voltage variation. Cell number, I didn't write it down, but 37, I believe. Cell number 37 was the highest reading cell voltage at 3.74, what I believe. Everybody else is at 3.68. These cars, lithium-ion batteries or lithium polymer batteries as this is, requires to have a maximum deviation of 0.02. Now the car could function with a greater deviation, but 0.02 is what it usually operates at. We have a deviation of about 0.05 right now. My best explanation for this variation could also be because we have a defective BMS, and because it is not a straight short or a straight defect in the BMS, but rather the BMS is sometimes communicating and then not communicating. It could be imbalanced, it could be not properly balancing the cells, causing this imbalance. It is my belief that possibly a replacement BMS may bring the modules back into line with each other, or worst case scenario, we may have to replace the entire battery pack. Right?